So hey friends, welcome back to our channel MVCS classes. So in the previous video we have learned the definition and meaning of half adder and full adder. So in this video we have got new three topics which are multiplexer, encoding and decoding. So we have got the same steps as we had in the half adder and full adder to solve multiplexer, encoding and decoding. The steps are, the first step is we have to make the block diagram. The second step is we have to make the truth table. The third step is we have to make the expression, and the fourth step is we have to make the logic circuit of the expressions. So what does multiplexer actually means? Multiplexer is used to describe one or more signals in a specified period, in a specified time or speed. So and multiplexer is also known as MUX, which is capital MUX. Now the very first step we have got to solve the multiplexer is to draw the block diagram. So if a question comes in the exam like 2 raised to 3, so this signifies that we have to multiply 2 3 times, so the answer we have is 8. So in this we have 3 selectors, 8 inputs and 1 output. In multiplexer we have to remember there are 3 selectors, which is the power of 2. So the power of 2 is 3. The answer is 8, so it means the inputs are 8 and every time the output will remain 1. So the block diagram will be of MUX and UX. So the inputs are 8, so 1, 2, 3, 4, 5, 6, 7 and 8. And the selectors will be 3. So 1, 2 and 3. And the output will be 1. So you have to name the inputs. So it will be I0, I1, I2, I3, I4, I5, 6 and I7. In multiplexer you have to remember the input starts from 0, not with 1. So let us add the selectors S1, S2, S3 and output. So let us draw the truth table, which is our second step. So our truth table will be of the selectors. So there are 3 selectors, S1, S2 and S3. So 4 zeros, 4 1, 2 0, 2 1, 2 0, 2 1, 0 1 0 0 1 0 1. So inside this left side or right side you have to write the inputs. So our inputs are I0, I1, I2, I3, I4, I5, 6 and I7. So now the next step we have got is to draw the expression. So this was our truth table for the multiplexer. Now we have to write the expression of the truth table. So the expression will be of I0, so which is input 1. So for the first one it will be S1 dash, S2 dash, S3 dash. Whenever 0 comes in the truth table, it signifies it is negative and 1 signifies positive. So and in the last we have to write the input. So I0 plus S1 dash, S2 dash, S3, I1 plus S1 dash, S2, S3 dash, I2 plus S1 dash, S2, S3, I3 plus S1, S2 dash, S3 dash, I4 plus S1, S2 dash, S3, I5 plus S1, S2, S3 dash, I6, and the last one S1, S2, S3, I7. So now the next step we have to draw the logic circuit of the expressions. So the final step, which is we have to draw the logic circuit of the expression. So here is the logic circuit on the board, so you can have a look. So the next topic is encoding. So encoding basically means we have to convert any integer number or a numerical number into binary digit. So the first step, which is to solve encoding, we have is to draw the block diagram. So the question is 2 raised to 2. So the answer will be 4. So 4 signifies inputs and 2 signifies the power, which is outputs. So to draw the truth table, we have to draw the truth table of the outputs, which is A and B. So A and B and the inputs. So if you come to the logic circuit, we have something different than multiplexer, half adder and full adder. So the diagram for encoding is this. So whenever you draw the logic circuit, we have to check ones. So in A we are getting 1 in I2 and I3, and in B we are getting 1 in I1 and I3. So our logic circuit for A will be I2, I3, this one, and I1 and I3. So our next topic and the last topic for today we have got is decoding. So decoding is basically the opposite of encoding. So decoding actually means we have to convert any binary digit into integer or any other digit. So the first step we have got is to draw the block diagram. So in encoding we had the number which we got in multiplying the 2 and the power. So they were the inputs and the outputs were the power. So it is in decoding we have a different case. So the power of 2 signifies the inputs, and the answer we get after multiplying 2 3 times. The outputs are this. So the truth table for decoding is different. For inputs, the truth table remains same as it is, and you might be wondering how I wrote the truth table for the rest of the part. So I will give you one short trick to write the rest of the part of truth table. So if you see the one, this, these ones are all in diagonal form. So you have to remember this trick. So whenever you draw the truth table for the decoding, you will be writing 1 here, this. And the rest of the remaining part will be filled with 0. So let us have a look on the expression. So expression will be same as we had in the multiplexer. So our first expression will be A dash, B dash, C dash, output 0, A dash, B dash, C, output 1, A dash, B, C dash, output 2, A dash, B, C, output 3, A, B dash, C dash, output 4, A, B dash, C, output 5, AB, C dash, output 6, and A, B, C, output 7. But the only difference come in decoding and multiplexer. In multiplexer we add all the expression at last when we draw the logic circuit, and in decoding we have to leave the expressions as it is. So our last and the final step for decoding, we have to draw the logic circuit of the expression. So this is the logic circuit, which is same as we had in multiplexer. The only difference in this we are having is we are not adding the expression as we added in multiplexer, and we have to name the expression wise. So the first expression of A dash, B dash, C dash is of output 0, and the next one. So you have to do this for each and every expression. So friends, we have come to the end of the video. So thank you so much for watching, and if you have any doubts, please comment in the comment section and like, share, subscribe. Thank you.